All right, a solid sphere is suspended by a string from a fixed support that forms a simple pendulum. The Q factor is 200. Well, 200, right? It's displaced so it oscillates. So discuss with reference to the Q factor the subsequent motion of the pendulum. So what's it going to do? Is it going to die down quickly, or is it going to take a long time to die down? You should know. Okay, the Q factor has something to do with that, right? So talk about that, right? And see if you can get 2 marks out of that, right? Okay, the point of P of the pendulum is now made to oscillate horizontally with frequency F. Okay, now notice that they gave us the period. Find the frequency. What is the frequency, right? What is 1 over 0.4? What does that equal? Gee, do you think it's 2.5 hertz, right? So for this one, this is the resonant frequency. So talk about the amplitude. If you drive it at the resonant frequency, what happens to the amplitude, right? And then talk about the phase of A, the resonant system. If you drive it at its resonant frequency, the system oscillates, and this is the one that's like 90 degrees, right? So look at that, right? We took notes on that. We talked about that, right? Okay. Interestingly, though, the phase is not in the mark scheme. I don't know why. Okay, but I got it right. I'm pretty sure, right? Then they say at 1 hertz, right? They drive it at 1 hertz. Well, gee, this system wants to oscillate at 2 hertz, right? So if you drive it at 1 hertz, it's like a fast oscillator, right? So fast oscillators have a certain phase relationship. So the amplitude's not going to be quite as big, right? Okay, so you're talking about the amplitude. It's not the resonant frequency by kind of a long shot, right? Okay, but then the phase relationship is interesting too, right? It is, and now this system is a fast oscillator compared to the driving frequency, right? So there is a phase relationship with that. We talked about those phase relationships. Look that up, okay? Look at your note guides for that, okay? Now let's look at the, oh, that's it.